And we're on. Right. So this week's homework was sequences and series, and it was a magnificent set of questions about the whole lot of the whole chapter. So we began with question 1. A sequence is U1, U2, U3. Oh, I can do the joke on the video. It's defined by U1 is 3 and UN plus 1 is 1 minus 1 over UN. Write down the values of U2, U3 and U4. So this is, what do we call this kind of sequence? What was the name of it? Nobody can remember.
Arithmetic progression.
Well, this isn't an arithmetic progression yet, we'll come to that. We call them recurrence relationships, or iterative formulae. The ones where the next term is generated from the previous ones. So U1 is 3. U2, the formula says that the next term is 1 minus 1 over 1 minus 1 over the previous term. So 1 minus 1 over 3 in this case, which would be 2/3. So we found U2, but we still haven't found what we're looking for. Thanks for laughing. And U3 is 1 minus the previous term, so 1 minus 1 over 2/3. Now, being a bit careful with the fractions with this, that's going to end up being 1 minus 3 over 2, isn't it? Which gives us minus a half. Good. So we found U3 now. U4 would be 1 minus the previous term, so 1 over minus a half, 1 minus 1 over the previous term. This time we get 1 take away. 1 over a half would be 2, wouldn't it? If you multiply by the reciprocal, and we've got to take away the negative, so it's add. So we get 1 plus 2, which is 3. And that, for the 3 marks, is all that part 1 wanted us to get. But have we spotted what then happens with this sequence? We've gone 3, 2/3, minus a half, 3, and the next term of the sequence always involves the previous term. So the next term would be what? 2/3, and then minus a half, and then 3, and then 2/3, and then minus a half, and then 3, and then it will keep going around these 3 terms all the time. So when we have described the behaviour of the sequence for part 2, there are a few acceptable answers for this. You could say it repeats every 3 terms. That's okay, because that's describing what it's doing, it's what it's doing. You could say it's periodic. Any of those words that we want. So periodic, repeating every 3 terms, oscillating, I'll take that as being a description as well. Okay, anything that describes the fact that we're just going to get the same routine going round and round. I have a feeling that actually there was a part 3 in this question when it was an exam question, and it said, hence find U100 or something like that, and you had to use where that would fit in the sequence of 3 repeating terms to work it out. There certainly have been exam questions that have done that. There we go. So that was 4 marks for that one. Question 2 on the homework said, the 10th term of an arithmetic progression is 21 and the 70th term is 141. Find the first term and common difference. So how are we going to set this up? We first need to interpret the information of the question. So somebody give me an equation that they established from that. What did you get, Ben?
A plus 9D plus 21.
So that's the 10th term is 21, so A plus 9D is 21. Brilliant. And the 70th term is 141. So what would that tell us? Go on, Matthew.
A of 69D equals 141.
Perfect. And there we have simultaneous equations, don't we? So what we're going to do with those simultaneous equations, what's the easiest thing to do to solve them? Go on again, Ben.
At the bottom of
equal than 1 and 2. If we do the second one, take away the first one, A take away A would be 0, 69D take away 9D would be 60D. 141 take away 21 is 120. That's not 120, is it? So D equals 2. 120. Good. So we've got our value for D. Fantastic. We need to find the value for A as well. So we're going to sub it back into the first equation. It does say find both. So A plus 18 is 21. So A equals 3. And there's your 4 marks for doing that. And then part 2, find the sum of the first 90 terms. So we've got the formula. It's on the formula booklet. Anybody remember what it is? Sum of the first n terms? N over 2.
2.
Yeah.
Plus n minus 1 times d.
Very well done. That's it. So that's the formula that does appear in the booklet. We've got the first 90 terms. So S90 is n over 2, 2 times A, which was 3, plus n minus 1, 89 times D, which is 2. Like that. And I haven't worked this out. I don't particularly want to do it in my head. What did you get? What did you get? What did you get, Ben? 8280. Does anybody else agree with that? There's some nodding going on.
If you
Fantastic.
got
If you've got the wrong values for A or D
but
in
they
this
carry them
part,
forward, correct?
then how many marks will we be given? You get 1. Okay. Then did it right.
Well, if you had the right execution part here, but you wrote it down wrong.
As in you wrote these two equations in, wrong?
Yeah.
It was 4, was it?
Yeah.
2? Okay. Now we get on to the very exciting third question. We've done the iterative formulae, we've done the AP, so now we're on to the geometric progression. Similar things going on here. The first term is 10, so we're going to straight away write down A as 10. The second term is 9.8. What does that mean, the second term is 9.8? If it's GP, how can we write that in terms of A and R?
AR equals 9.9.
Yeah. You're on fire today. AR is 9.8. A is 10. So R is 9.8 divided by 10. If we divide through by A. 9.8 divided by 10 is going to be 0.98. So we found the common ratio. The question said find the sum to infinity. And remember, we just did this at the end on Friday. GP has a sum to infinity, providing R is between -1 and +1, and it is. And the sum to infinity, again it's on the formula sheet, is this formula A over 1 minus R. We know what A is, it's 10. R is 0.98, so we've got 10 divided by 0.02, which is 500 as required, and there's 2 marks for that bit. Now it gets really exciting. The sum of the first n terms is greater than 499. Again, it was a bit unfair giving you this because this was only Friday that we wrote this down, but the sum of n terms of a GP was A times 1 minus R to the n over 1 minus R. This has got to be greater than 499. So, A, 10 times 1 minus 0.98 to the n over 1 minus 0.98 has got to be equal to, oh, it's got to be greater than 499. So we need to try and solve this. If what we've got here is 10 divided by 0.02 again, haven't we, which is what we had there. So that's 500 times 1 minus 0.98 and is greater than 499. I don't know how you did this. I would probably now divide through by the 500. I'll leave it like that for now. Let's rearrange this a little bit. If we add 0.98 to the end to both sides and take that away from both sides, we've got the equation looking like that. And if you think where we were heading for, it was that answer that's up there, and we've got it, haven't we? 1 minus 499 over 500 is 0.002 as required. So that's got us started. The question said show that that was true. Now we've got to try and solve this. And again, it gave us a hint. This is what we did just before Christmas, using logarithms to solve it. We've got to solve this inequality. So we're going to take logs of both sides. Log base 10. What happens here when it's log of something to the power n?
N goes to the front.
N goes to the front. Bring n down to the front. So n log 0.98 less than log 0.002. I've got that right in a minute. Yeah. We then, now we need to divide, don't we? We've got n times something is less than this. So we're going to divide by log of 0.98. But this is the bit where I expect some people to have gone slightly wrong, because there's a really nasty hidden moment in this. With inequalities, you have to be really careful. If you divide an inequality by a negative sign, what do you have to remember to do? Flip the inequality sign round. It's not obvious, but the log base 10 of 0.98 is negative. So at that point, because we've divided by something negative, check it on your calculator. If you do log 0.98, it's negative. This now looks like that, once you divide it by that. Do check it on your calculator. If you do log 0.98, you get minus 8.7 times 10 to the minus 3, so minus 0.00087. Okay, it's really, really small, but just negative. Final thing then, n is greater than this lot. So n is greater than, we put it into the calculator, that's log 0.002 over log 0.98. We get 307.6. 613, leave 3 additional places. So, hang on, what is n? What does n, what does it stand for? Just a letter in between O, another letter.
It's the number of terms, so it has to be a whole number.
Brilliant. It's the number of terms in the sequence, so it has to be a whole number. So if it's going to be bigger than 307, and it has to be a whole number, the smallest value that it can be, the smallest possible value of n is 308. And that was really tough, that question. But that is your 6 marks for that. It would be great if anybody got. Did anybody get all of that right? Nice work. And Rachel did as well. Really good. 6 marks. 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 6 mar Right, and that's that. Are you ready to start the video? Well, and that's maths.